Hello, welcome back to LearnSBOM. My name is Brian, and today we will explore Ko, a tool that simplifies building and deploying Go applications to Kubernetes. We will walk you through the process of creating an image, deploying it onto Kubernetes, and also cover a recent feature that generates SBOMs. So Ko is a CLI tool designed for Go developers who want to build and deploy their applications to Kubernetes. It streamlines the process by automating containerization, pushing images to a registry, and generating Kubernetes manifests. Now that you know what Ko does, let's dive into how to use it. There are various ways to install Ko. If you are on macOS, you can use Homebrew. On other operating systems, you can download the binaries directly from ko.build, which is this website, or you can download and build the repository yourself. This is what we will be doing for this overview. Alright, so once you have the Go command line tool and language installed, just run go install github.com/google/ko at latest. This should put the binary in go path/bin. We can check that with ls go env go path/bin. And as you can see, it's right there. I've added this to my path, so I can use it by just running Ko. Now that we have Ko installed, let's get it set up. Ko does not have a default registry, like Docker and many other programs that use images. So you have to find the correct URL for your use. Right now, I have a Docker registry running on my computer. You don't have to run your own, though I am doing this for this demo. This allows me to push any Docker images that I create to this private registry. Now, to tell Ko to use this registry, I need to do export ko_docker_repo equals localhost 5001. As you can see, the registry is running on port 5001, pointed to port 5000. Alright, so now we have everything set up. To get started with building an image, go into a valid Go project. I have one open right now called Gother, but you can use your own. We just need to run ko build. And as you can see, the image has been created. Instead of just building it though, sometimes you may want to run it immediately in the Docker container. Since the output of ko build is a valid manifest, we can also just run the image in a container through Docker. We just run docker run -p, we'll do 0.8080, then we do ko build. And as you can see, the image has been created and the container is running. All of this is quite standard and actually pretty easy to do with just Go tooling and Docker. What exactly makes Ko stand out as an independent tool? Firstly, Ko makes it wildly easy to deploy to Kubernetes. If you've ever worked on a team project built to run on Kubernetes, you know about the struggle of redeploying your own version on a test cluster. Ko makes it quite easy to do this by generating a deployment for you with the registry, image name, and image hash. It acts as a sort of template. Let's take a look at this. We do cat author deployment, and this is the deployment template that we have. The important bit is down here where you can see ko://github.com/ftqo/author. This is the same as the name of the Go module. Now, to generate the new deployment file, let's do ko resolve-f gother deployment. And this is a valid deployment file. You can either pipe this into kubectl, or you can run this other command, ko apply-f author. And there you have it, a Kubernetes cluster running the image that you just built without dealing with Docker files, manually changing your deployment files, or anything of the sort. To tear these resources down, just run ko delete. Those are all of the main features of Ko. What you're here for is SBOMs. You may have noticed that SBOMs were indeed being created as the images were being created, but how do we access those? For that, we need a different tool called Cosign. We will have a video that gives an overview of Cosign later, but for now, I'll do a quick run through. Assuming you've made it through the whole video so far, you should have the Go language installed. To install Cosign, run go install github.com/sigstore/cosign/cmd/cosign at latest. Then just run Cosign, download SBOM, and then we do the registry, so that's localhost port 5001, and then / and we do this right here. And as you can see, this is the SBOM that was generated by Ko. If you want an SBOM in a different format, you can specify the format with most other Ko commands that result in a new image. So that's ko build, ko resolve, ko apply, any of those. So let's try that. Ko build -- SBOM, equals CycloneDX. Now let's take a look at that. Cosign, download, SBOM, and then we can copy this right here. And that's a CycloneDX SBOM. Overall, Ko is a tool that most teams will not need. Most of what Ko does is actually relatively easy to do on your own. Building a binary is just a single command with the Go command line tool. Writing a Docker file is also quite simple, and it provides the authors of a codebase with much more capabilities. Even writing a script that creates builds for multiple platforms is accessible with both Go and Docker. However, a team that wishes to do all of these and deploy to Kubernetes with one streamlined command could save time instead of creating a DevOps system. That's it for me. Thank you for watching. Bye-bye.
Thank you for checking out this video. If you really liked it, be sure to check out our other videos right here, and then you can also subscribe right up top here. And again, thank you. Bye-bye.